So now we'll talk about chi-square. We have said statistical tests used to determine statistical tests used to determine if there is significant association, if there is significance association between categorical variables. And a good example of categorical variable, the love and honesty. So honesty and love is a good example of categorical variables. Into bracket, non-parametric. So a good example, non-parametric. So you can find what is non-parametric. So non-parametric variables are variables which you cannot quantify. So these are variables. These are variables which is hard to quantify. So yes, we can quantify, but it is very hard. So it is because of that nature. So we cannot collect the data of love and the data of honesty, and then we do analysis. So in that case, it is very hard. And if we have the data, then we can only use chi-square, but it is we cannot easily say the relationship. So it is there that just to help. So we can say they are non-parametric. They are non-parametric. They are non-parametric because they do not assume. They do not. So they do not assume. So they do not assume a specific distribution for the data. A specific distribution for the data. So tunasema they are non-parametric because they do not assume a distribution for the data. So that's all about chi-square. So we need to also discuss about type of chi-square. So we have 3 types. So number 1, we have the goodness of fit. We have the one for independence and the one for homogeneous. Yes. Ama nimeandika kidogo kidogo lakini iko sawa, sio mbaya. Yeah. So let us look at type of chi-square. Type of chi-square. So number 1, we have the one for chi-square, goodness of fit. So chi-square, goodness of fit. Goodness of fit. Chi-square, goodness of fit. Okay, well, let us see what that means. So for goodness of fit, the goodness of fit test, and we say it determines if a sample data matches a population with a specific distribution. So this one is where the sample data, it determines whether the sample data matches with a particular population. And this is the formula. So the chi-square is given by summation of O minus A squared over A, where O is the observed frequency. So OI, observed frequency, EI, the expected frequency, Then we have the last one, x squared, the chi-square, chi-square, so which is the x squared. We can do a past question from our past paper for this one before we proceed to another example. So let me see. Let me see a question from past paper. Then we do. So let us open our past paper. For this sitting, the sitting is, let me see the one for goodness of fit. The one for goodness of fit. We had one. I think two of them. Let me start with this one. December 2023, number 3C. December 2023, it's number 3C. December 2023. Question number 3. Number 3C. So let me open that December 2023. We do a question for us to explain further. So I hope inaweza toshea hapa sababu iko sika kubwa. So nitajaribia hapo. But I think hapo itatoshea. So leo tufanye chi-square na to introduce hypothesis hadi part fulani. The next time tukikuja tumalizie hypothesis, tuingie descriptive statistics. So December 2023, question number 3C. Nilisema kweli? Let me check. Was it December? Not, oh yes, 3C. December 2023. number 3C, a revenue authority research department conducted a survey that revealed the number of companies that were reported as being tax compliant the last 6 months for the year 2022, as recorded in the table below. So you have the number of companies and the month. Now, we cannot easily quantify with this information. So we just have the number of company and the July. So we cannot easily relate and say that in July, the real company complied or did not comply. Reason why? Because we have to the number of company. So we don't know if they complied or not. And therefore this one is hard to quantify because we have the month and the number of companies, but the level of compliance is very hard. Now we were required to test the hypothesis that the number of compliance does not depend on the month. So it is very hard because that is the information we have. So in this month, we don't know the level of compliance. So kama tulikuwa na level of compliance, then maybe tungesema chi-square is not applicable. But in this case, we only have July and only the number of companies. So we cannot easily say. So the only way it is use chi-square. Now, what you do, so December 2023, question number 3C. So you have to test if this companies complies or not. So the first thing that we do, you can state your hypothesis. You can decide to state your hypothesis. So how shall we state the hypothesis? Let me kuna kitabu yangu fulani inaitafuta. So we can state the hypothesis for this kind of a question. So let us try and see if we can state. So we can start by stating hypothesis. So step number 1, we state hypothesis. And we have 2 of them. We have the null hypothesis and alternative. But we shall explain more of this one tukifika kwa hypothesis. But for now, just know we have 2 types of hypothesis, the null. So the first one, it is usually there is no relationship. The second one, alternative, usually says that there is relationship. So rather than the first one, which says that there is no, so the same, there is no relationship. So there is no relationship. Ilikuwa nini? There is, we say, let us use the word of the examiner. Use the number of the word of, so we say there. So we say the number of tax compliant companies, depends in the month of the year. Depend in the month of the year. So remember the word of the examiner, required. So test the hypothesis that the number of compliant companies do not depend. Then we state the null hypothesis. We say the number of tax compliant companies do not depend supposed to be on the month of the year That's step number one. We are supposed to state the hypothesis. So we are supposed to state the hypothesis. Step number two, we come up with significance level. Na kwa Swahili yetu wametuambia what is significance level in this question? So Swahili wametuambia we test at 1% significance level. Now, when we talk about significant level, what do we mean? So significant level in just a normal language is the amount of evidence required to reject a proposal. So we talk about significance level, we mean it's the amount of evidence required to reject a proposal. So if you want to reject a particular proposal, so that amount of evidence that is required to reject a proposal, so we call the significant level. Step number three, so number one, number two, number three, test statistic. Test statistic. Now our test statistics is chi-squared. The formula is here. Summation of O minus E squared over E. So we have it here. So you shall allow me to rub this side. The malizia on this side. So let us come up with the table. So we have the month. So we have the month. Then we have the month. And then we need our observed. Then our E. Then to marry O minus E squared over E.
Ngoja Darren, unajua mimi nasoma. Kama iko na space wacha anaweza tumia kufanya kazi ya homework. Weka huko space, weka huko. Sio iko na spaces, weka huko.
So hapo inaonekana sawa sawa. So we have what I tuweke hizo figures ndio tuweke in box. Usije tukanini. So where is our first paper? So we have 326. No, up 326. That one is the observed. What we have for July. Then we end July, August. August we have 290. We have September. September we have 306. We have October.
Calculator niangalie calculator hapa ndani.
260. November. November we have 355. December we have 365. Now we find the total. In this case, hapa ni tofauti kidogo. Utaona notice na hiyo ingine tukifanya hiyo nyingine but a bit different. Let us add them together. So we add them together. so that we can get our expected. So our expected is equal to the total over n. So what's our n? 1, 2, 3, 4, 5, 6. So our n is 6. Let us add together 326 plus 90 mpaka mwisho.
1902.
1902.
Yeah.
So 1902. We have it 1902. We divide by 2. So for this kind of a problem, the goodness of it, the total are always the same. And then the expected will also be the same. So 1906, 06 divided by 6, which is
1902. 317.
1902. Or 1902, maybe 1906. 317. So they will all be the same. 317, 317, 317, and 317. Now we can get the expected this one, sorry, this amount, summation of O minus E squared over E. So we need 326 minus 317 squared. Once you square, you divide by 317. Unapata 0.25. 25. Then introduce 2 decimal place equal to 6. Then next, 290 minus 317 squared. Then we divide by 317. 2.3. 0. Then you have 306 minus 317 squared divided by 317. 0.3. 0.38. Then to 60 minus 317 squared divided by 317. This one is 10.425. 25. So now I can do decimal place. 355 minus 317 squared divided by 317. This one is 4.56. Then this 65 minus 317 squared divided by 317. So make sure umefanya pia so that we can compare the figures. So add them together to get this figure. Now if you go to pata hapa, it is what we call the x squared. That figure is what we call the x squared. That figure is what we call x squared. So how much is that? Mapana ngapi?
25.02.
25.02. Ninge iko sawa. Now that one was step number. So tufanye step number 1, step number 2, step number 3, test statistics. And the way hapa, so our x squared is 25.02. Then we do step number next. Tunasema in step number 1, step number 2, number 3. So step number 4, decision rule. Decision rule. Now for decision rule, we need to get the degree of freedom. Now also here, the degree of freedom for goodness of fit ni tofauti. It is only so degree of freedom So degree of freedom is n minus 1. We shall explain it later, much. But for now, it is n minus 1. Just know for you to get the degree of freedom n minus 1, which in our case, it is 6 minus 1, which is 5. So number of n, 1, 2, 3, 4, 5, 6. So 6 minus 1, which is 5. Now we need to go to our table. Remember, we stated that our significance level is 1%. So let's go to our table. So kwa paper yako, that table is in page 32. So go to page 32. Utapata hiyo square table. Page 32. So that we see how we can read it. So remember, the significance level is 1%. So page 32 ndio hiyo table iko ndio wameweka. Kwa hiyo past paper yetu yenye nituma kwa group. So chi-square, can you see it? Chi-square distribution table.
Yes.
So we have the degree of freedom on horizontal. Then we have the level or significance level on the other side. So tunaangalia, so 1% means 0.001. Yeah, so unaenda kwa mwisho kabisa. We have the 0.01 kwa mwisho kabisa. Then unateremka kufika kwa 5. So unaenda kwa degree of freedom kwa 5. Then unaenda kwa huku mwingine. Unapata expert ngapi? So this one, let me put it kwa rahisi. Hii tumecalculate hapa. Tuite x squared calculated. Tuite x squared calculated. And then hii itaitafuta saa hii
Choma uweke ndani.
Critical. X squared critical. So niweke cric. So cric means critical from the table. So ni ngapi from the table? So kwa 0.1, 0.01 alafu kwende kwa 5, kwa degree of freedom 5 au kwa kona huko. Figure unapata ngapi? Yes.
How do we read the table, mwalimu?
Umeipata table ama hujaipata?
Yes, I have the table.
Oh, sasa kwa hiyo table,
yes,
uko na degree of freedom iko 1, 2 mpaka 5. So kwa hii 5
yes,
tunaenda mpaka kwa penye yetu iko 0.01. So nateremka penye zinakutania hapo, that figure ndio our x squared critical. So degree of freedom nateremka penye iko 5 na penye 0.01 iko penye zinakutania. So nateremka chini na huyo anaenda hivyo. So penye anakutania, that is our critical figure. Umepata ngapi?
15.09. 15.09.
15.09. Now the last part is decision rule. Not decision rule, conclusion. So the last part, once we have this one, now we compare x calculated with x critical. So tunasema you compare x calculated. You compare x calculated with x critical. So x calculated with x critical. Now, in this case, kama inaonekana hapa chini, niendeleshe tu hapo. For conclusion part. I think inaonekana. So conclusion. Now, x squared is greater than x squared calculated is greater than x squared critical. And therefore, so if calculated is more than critical, we reject the null hypothesis. But if calculated is less than the critical, we accept. So in this case, so tuendeleshe hapa, just continuation ndio hapa. So tunaendelesha hapa. So we say x squared calculated is greater than x squared critical. Hence, we reject null hypothesis. Now we reject null hypothesis. Then ya mwisho, the last step, the meaning. So what does this mean? So remember tulikuwa tumesema that the number of tax compliant under HO null hypothesis, the number of tax compliant depends on the number or the month of the year, but we have rejected the null hypothesis. Therefore, we can say the meaning. It means, so this means that the number of tax compliance company related to month. Tax compliant company relates to month. Relates to month. So we have concluded at this table that the number of companies, compliant companies, relates with the month of the year. So they have an association. So using chi-square method. So they have an association. So assignment, hebu tafungua uone kama it is possible. Kama si possible, you can tell me to do it. But let me show you another one that was tested. August 2022, question number 1C. August 2022, question number 1C. August 2022, question number 1C. So August 2022, question number 1C. So August 2022, question number 1C. So open that one. So August 2022, ikoaje hiyo? We can try it at one time, Silvio. I think that one you can try it. Sawa, I think iko sawa. That was for August. I think August 2022. Question number 1C. You gonna days of the week, Monday, Tuesday, back up Friday. And then you are required to test. So wajakwambia, but hiyo unafaa ujue tu ni chi-square. Number 1C. Number of employees working online during a particular week was recorded as follows. So test the hypothesis that the number of employees who work online depends on the number of days. Now, we cannot easily say that the number of people who work online depend on the number of days. Maybe Monday, Tuesday, Wednesday, Friday. Unaweza pata pia Sunday wako wengi. maybe Sunday ndo kazi mingi za online ziko, so we cannot easily say that it is on Monday or Tuesday that we have the number of. So that relationship is very hard to one. Kitu ya kwanza, number of in Monday. Monday is not a variable, so we cannot quantify Monday as a number. Same na hii swali, we cannot quantify July as a number, and therefore in this kind of a question, it is only chi-square which is applicable. So iko sawa, that one you can check.
Yes.
No, I think that one is fine. So let's try and introduce a hypothesis. Maybe we do just a small thing, then itakuwa sawa, so that kesho tuende tumalizie hypothesis, so tufikirie mambo nyingine. Oh, hatujamaliza chi-square. Then next. Kuna hatujamaliza. Na niko na haraka. So we go to the next type. Let's go to the next type of hypothesis. Mimi niko zangu. Let's go to the next type of hypothesis. So allow me to do away with this one. Let's go to the next type. So the next type is the independence. That one is very common in an exam. The last one ndio hakiko kwa exam, so hiyo sijawahi iona. But number 2, type 2, chi-square, test of independence. So this one inakuanga poa, napenda mimi, I prefer this one. Test of independence, and we say it determines if there is an association, if there is an association, so it determines if there is an association between two categorical, variables in a contingent table. So each table when we have some item this side, some item on the other side. So we have number of days, now we have pay. So we have two items within the same table. That is what we call the contingency table. Contingency, not contingent. Contingency table. Contingency table. Formula. So this one is very important, but this is a ile mwingine. So O ij minus E ij, then we square it, divide by E ij. So tuseme OIJ is observed frequency. Observed frequency on cell IJ. So on cell IJ, so hiyo tu ni ya kuonesha, so kwenye hiyo cell iko, then expected frequency on cell IJ. Then we have another formula here. So EIJ is calculated as follows. So how do you get EIJ? Now this one, this is how you calculate it. For the goodness of feet, unachukua total divided by n. In this case, this is how you find it. Row total times column total. Nipeleke chini kidogo isikane na ile. So we have the row total times column total over the total. We call it the grand total. So that's how you find. That's how you find expected frequency. So kumbuke ni tofauti na goodness of fit, where we say goodness of fit ilikuwa total divided by n, but hapa ni row total times column total, we divide by grand total. Then you have the degree of freedom. Degree of freedom, in this case, it is equal to row minus 1 over column minus 1. So this is how you get the degree of freedom. That's how you get the degree of freedom. Now, I think now we can jump to a question. So let me show you where we can find such kind of a question. So tunasema R, number of row, C, number of column. In case, so R, number of row, C, number of column. So let us go to our past paper. So this one, let me see. Let us try this question. So I think we have two questions. Let me see. 2 or 1. Mimi ni maana tu moja kwa past paper. I think sijaona nyingine. So there is question of sasa ni which sitting? April 2022. April 2022. April 2022. So the question for April 2022. April 2022. I think question number 3 is C. So April 2022. Question number 3 is C. If I'm not wrong. So let us allow me to wrap this one. Hapo umeandika. So allow me to wrap this one. Sawa sawa. You kama umepata hiyo swali, the one for April 2022. Wacha nione. So April 2022. Yes. A certain new strategy K came to be effective for teams playing a certain game. In a match of 100 games, half of the team use K and half use P. Alafu, the team performance was recorded as follows. So on the basis of the above data and using chi-square method, advise whether there's significant difference between the two strategies. So that's when we need to come up. So step number 1. So we are supposed to state the hypothesis. State the hypothesis. So we have HO and HI. So we can say there is no significant difference between two strategies. There is no significant difference between the two strategies. I think mimi watu hivyo tunaweza sema kulingana na hii swali hapo kwa required on the basis of the data and using chi-square method, advise whether there is significant difference between the two strategies. Tutasema there is significant difference. There is significance difference between two strategies. Between the two strategies. Then you can also comment with this one. There is no significance difference between the two strategies. Step number 2, we state the significance level. Significance level. In this case, umetuambia ni ngapi? So wajetuambia, so tujipe ngapi? 5%. So that one is we state the significance level. Then next, test statistics. Test statistics. So the x squared. So we have, so here's what we can table. So tuko na won, defeat as nimeka DEs. Then we have draw as DRA. We have strategy K. Strategy K. And we have strategy P. The figures need We have 130, 110, 20, 30, 60, 50. Then we need total. Then we need here total. So in the table inafaa ikuwe. Unafaa kuja na hii table. This is the table that you need to come up with. So let us come up just your table. So now tunataka tukiteremka. So 130 plus 110. So tukiteremka. So 130 plus 110 into 40. Hii ni 50. Hii ni ngapi? 60 plus 50. This is 110. Twende ingine. 130 plus 20 plus 60. This one is to 10. 110 plus 30 plus 50, which is 190. Then we get the total. I said it was 400. So the total was 400. So to 40 plus 50 plus 110, 400, or to 10 plus 190. Ukichukua huyu plus huyu inakupea huyu, ama huyu plus huyu 400. So huyu plus huyu ni huyo, huyu plus huyu ni huyo, then huyu plus huyu ni huyu, huyu plus huyu ni huyu, huyu plus huyu ni huyu. Now once tumekuja na hiyo, then next thing we need to come up with our E. So how do we come up with our E? So, I think hapo iko sawa. So let us come up with our table. So we start with observed, which is our O. Expected, which is our E. Then tukumalizia na O minus E squared. Then we divide by E. So tunaanza na observed. Tuko na 130. Tuko na 110. Tuko na 20. Tuko na 30. Tuko na 60 na 50. Ni kama inaonekana. So those are our figures. So next ni kutafuta expected. Na nilikuwa nimewapea formula. Alafu ya mwisho itakuwa ni x squared. Nika inaonekana. So I'm just going to do this x squared. So let's calculate it. Tunasema formula ni gani? Nilikuwa nimepewa formula. So what was the formula? Tulisema row times column over the grand total. So row total times column total divided by the grand total. So those are 130. Hapa 130. So what is the row total? So row total ni ngapi? So row ni hivi ama ni hivi? So ni 210.
210.
Times our column total for 130. 240. Then divided by the grand total. Grand total need the total of all, which is 400. So this one is 126. Aya, tukimaliza tunaenda kwa 110. So kwa 110, the row total ni 190 multiplied by 240. Then everything we divide by the grand total, 400, which is 114. Tunaenda kwa next ni 20. Total column ni 210 times 50 divided by 400, 26.25. Tunaenda kwa 30. Total 190 times 50 divided by 400, 23.75. Then total here 60, 10 times 110 divided by 400, 57.75. Then tumalizia mwisho 190 times 110 divided by 400, 52.25. Now find E. So tunaanza ya kwanza 130 minus 126 squared divided by 126, which is 0.13. Let us round off to a whole figure to do 2 decimal place. Next 110 minus 114 squared divided by 114, 0.14. 0.14. 20 minus 26.25 squared divided by 26.25, 1.49. 30 minus 23.75 squared divided by 23.75, 1.64. Then 60 minus 57.75 squared divided by 57.75. 0.09. Confirm that one. Nakao not correct. Squared.
0.09 is okay.
Okay. Then itakuwa ni 0.10 round off 2 decimal place. So round off in 2 decimal place, itakuwa 9 plus 1 ni 10. Itakuwa 0.1. So add them 0.13, 0.14, 1.49, 1.49, 1.64, 0.09, 0.1. So 3.59. So remember this one is x. Remember this one is x squared calculated, which is 3.59. So step number 1, state hypothesis. Step number 2, we come up with the significance level. Number 3, we do the test statistics. Number 4, we do the decision rule. So decision rule, we can do it here. Decision rule. Now for decision rule, we need to come up with x critical, x squared, critical. Now at which level? So alpha tulisema ni ngapi? 5%. Na pia remember the degree of freedom. We need to come up with the degree of freedom. Let us complete the degree of freedom. Tuweke hapa. So degree of freedom tulisema ni row, number of row minus 1, number of column minus 1. So what is the number of marker hapa? Ignore the totals. Ignore the totals. Number of row 1, 2, 3. Ni ngapi? Ama ni 3? Nisaidie ama nisaidie? Number
3 rows.
is it equal to? Huku ni 3, 1, 2, 3 na huku ni 2, 1, 2. The number of row ni side gani? Ni either itakuwa the same answer. So 2 minus 1 ni 1, 3 minus 1 ni 2. So degree of freedom ni 2. So we go to our table, we find the x critical. So ilikuwa page ngapi hiyo? Our table was on page
32.
Yeah, 32. Let's go to page 32. So unaenda kwa 5%. So hiyo ni 0.05. Alafu unaenda chini kwa 2. Then you pick that number. So that number we thought we shall compare with our x calculated. So 0.05 and then kwa 2. 5.99. 5.99 according to what nimepata.
Yes.
Now conclusion. Now our x squared calculated is greater than our x squared. No, it is less. The next year, critical. So what is our conclusion? So do we accept or do we reject?
We accept.
We accept another hypothesis. So we say accept the null hypothesis. And then ya mwisho, the meaning. So the meaning unachukua tu kwa your hypothesis. So we have accept the null hypothesis. Kama we accept now, we say there is a significant difference between the two strategies. So we say there is significant difference between the two strategies. So that is the test for independence. So there is a significant difference between two strategies. So tunasema this significant difference between the two strategies. So that one is all about the chi-square. The other one, so neither two mbili. Once you know those two, I think it is fine. So let me give you some ya hiyo mwingine. Then tomorrow we start hypothesis. So tomorrow we start on hypothesis.
Mwalimu.
Yes.
When you get tested on this chi-square,
yes.
How do you know when you're supposed to use the chi-square test of independence and this other one's chi-square goodness of fit test?
the contingency table where we have this kind of a table. So now walikuwa wamekupatia hiyo table venye inakaa. Tuko
Yeah.
na some amount this side na wengine huku kando.
Yeah.
But ile ingine wamekupatia direct. You observe wamekupatia direct kama laini tu.
Okay.
Hapa kuna mbara mbili. Tuko na some figures on horizontal, the strategies. Na hizi zingine we have the ratio of either win, draw or defeat.
Oh. Okay.
Sio katebo sumona mekanaka.
Yeah.
So that is if you get your table, once you see the contingency table, utakuwa umepatiwa, unaweza pata na amekwambia we have number of students A and B, then maybe month, maybe January, February, March. Na huku ni student. And then upatie in form of a table, then that one automatically the sense of independence.
Independence. Okay.
Sasa. So ya mwisho haina hesabu. Just let me give you the note. And then so it is called the test of homogeneity. Homogeneous. Without homogeneous. Homogeneous means what? Is it the same or what? So let us malizie na huyu. So number 3, chi-square test for homogeneity. Karama iandiki. Haya. We say it determines if the different sample comes from population with same distribution. Then we say NB similar to test of independence during calculation. So it also uses the contingency table. Na ndio hii this is a good example for contingency table. Hii tulikuwa tumeweka hapa. That's a good example of a contingency table. So that is all about test for homogeneity. So that's the cascade test for homogeneity. Now with that one, we can now say we have completed chi-square test. Now from the past paper, not from private paper, from our coastal train, this one is under hypothesis. Na ukienda kwa coastal train unasema what you are supposed to do. or what is supposed to know for exam purpose. So ukienda kwa console train, kama uko nayo uende kwa hypothesis testing, then uende the second last point, wanasema chi-square test of goodness of fit and independence, na inaishia hapo. Hakuna mahali wameongea mambo na homogeneity. So kumaanisha this one is not a requirement in this level. So you concentrate with a chi-square test for goodness of fit and the chi-square test of independence. So tomorrow we start with the hypothesis testing. So shall be tomorrow. So tomorrow we shall complete hypothesis so that we do the descriptive statistics. So that's all.
Okay. Leo ni mvua.